Okay. Next one. Can you guys see it all right? I didn't close blinds or anything this time.
Yeah.
Which graph appears to be non-linear? What do you think is non-linear? Non-linear. Anyone? Non-linear. B? Yeah. Everything else looks linear, right? Okay. Refer to question 1. Which graph shows a positive rate of change? Positive rate of change. You might also have heard rate of change being slow. Yeah, it's okay. It's increasing. Which graph shows? Smart pants. Which graph shows a negative rate of change? Negative rate of change. D. Just joking. Okay, which graph shows a 0 rate of change? A, the rate of change doesn't stay, it's straight. Okay? Okay, so we're pretty easy here. Okay. Sida? Right? I think it's Sida. Jog at a constant speed, traveling around a 400-meter track in 4 minutes. What is Sida's rate of change of distance with respect to time in meters per minute? Okay, so they're telling us that she is going a 400-meter track in 4 minutes, right? So we know she's going 400 meters per 4 minutes. Does everyone agree with that? So can that be reduced? Can it become 100 meters? Oh, sorry, that should be better. 100 meters per minute. Does everyone agree with that?
Yeah.
Thanks, Stephen.
Yep.
I appreciate everyone showing that they understand. Okay, Sida continued jogging at the same speed. How long would it take him to jog around the track 5 times? Okay, continued jogging at the same speed. How long would it take him to jog around the track 5 times? Okay, so does everyone agree that it takes 4 minutes to go around the track once? It says that at the very start of the question. So if he's going 5 times around the track, how many? It'll take 20 minutes. You guys are just. You guys are gonna love this unit. You're gonna fly. I like it. I'm down with it. So it'll take 20 minutes. I am absolutely fine with this. Okay. Okay. Concrete used to construct tall buildings must be pumped vertically up to where it is needed. A table shows the time required to pump 30 meters cubed of concrete to different heights. Okay. Does the relationship between height and time appear to be linear or non-linear? First things first. We have time and height. Does everyone agree? In our table, that's fine. For it to be linear, there needs to be a constant difference here as well as here. Okay? So, if we're going 60 to 67, right? Okay? Then, so that's a difference of, 60 to 67 is a difference of 7, right? No, I didn't. Yeah. 67 minus, okay. So now, if you keep adding 7, you should get to the next numbers, right? 67 plus 7 gives me 64. 64 plus 7 gives me 81, and so on. So I know my time's good. I'm consistently going up by 7. So I'm going up by plus 7. Up by plus 7. Up by plus 7. Everyone agree with that? So now I want to check my first differences. Because if I calculate my first differences and they are constant, then I know it to be what? Linear. Thank you. So right here, right? If I go 120 subtract 100, I get 20. Here, if I go 140, subtract 120, I get 20. Does everyone agree with that? And 180, subtract 160 gives me 20. Is that number constant? Because my first differences are constant, what type of graph is it? Okay. So because first diff are constant, it is linear. Okay? So this is my first diff right there. Okay, those are my first differences. Okay, could you find the rate of change, meters per minute, without having to graph this? What would the rate of change be? Okay, yeah, so it's going to be, what do they want? They want meters per minute, so it's going to be 20 meters over 7 minutes, which we can actually, I know it'll be a decimal, but you can do it. You can go 20 divided by 7. So it could, again, this is rounded. I'm going to go 3 decimal places just to be a bit more accurate. Meters per minute. So it would be 2.857 meters per minute, or you can leave it at 20 over 7. Okay? You can leave it as the 20 over 7, or you can actually do the division and tell me that it's 2.857 meters per minute. Okay, now I'm just going to remind you this. Rate of change is actually the difference in, rise. So rise over run, right? So it's the difference in y over the difference in x. Does everyone agree that this is x and y? And we calculate the differences, right, by saying, well, 20 over 7. So that's how we're getting that rate of change there. Okay? X is always on the bottom, and y is always on the top. And that's why we needed to make sure that our x's were constantly increasing by the same number too. Right? Because if our x's hadn't have been constantly increasing by 7, this wouldn't work. Yep, Helen? Okay, sweet.
Yes.
Everyone remembers this? You do start this in grade 9, I believe, because I think it's on the QAO. Okay. Draw a graph with time on the vertical axis and height on the, horizontal axis and height on the vertical axis. Does the graph match your answer to part A? Explain how you know. Okay, so predict the time. Okay, so then there's actually multiple questions. So someone's going to have to give me the information from the table because I don't have it. What's the first ordered pair on that table you guys have on your chart? 60 and 100. So I come up here, 60 and 100. What's the next one I have? 65 and 120. Okay, next. 74, right? And one,
70.
oh, 70, okay. One what?
67.
67. So I'm going to be like in here. Thank you. 67 and 120. Okay, next one. 74 and 140. Okay. Okay. Okay, does that look linear? And of course yours could be even better than mine because you have a ruler and they're not doing it on the smartboard. Okay, so does the graph match your answer to part A? Explain how you know. Do we know by just looking at it? Do you know by looking at it that it's a linear graph? Okay, by looking. Okay, what is the rate of change of time with respect to height? Remember to include the unit. Now this is going to be harder for me because I haven't put like little dashes. If you were actually graphing this, what you would want to do is sort of put little dashes. So like 61, 62, 63, 64, and so on. My calibration is off. But what you would want to do is actually put these little dashes in so you could follow it. Now to calculate your rate of change, what you want to do is grab this point and this point here, and I'm going to just go to a different color, and tell me from here and then from here, what is your change? Triangles mean change, right? So, can someone just remind me, this was 67 here? Was this 67? 67. So does everyone agree that that's a change of 7? From 60 to 67 is a change of 7? Okay, now from here to here is a change of 20. Everyone agree with that? Because I'm going from 100 to 120. So did I get the same rate of change? Yeah, my rate of change is still equal to 20 over 7. Okay, rise over run, right? How many am I rising from one point to the next? I'm rising from 100 up to 120, so I'm rising by 20. How much am I running from one point to the next? I'm running from this point and over 7. Okay? Depends how your teacher would have taught it, if you would have heard rise over run or rate of change, depending. Okay. Predict the time required to pump 30 meters cubed of concrete to 200, a height of 200. Pardon? 2 hours. So basically, I'm going to just show. Basically, what you want to do is extend up here and hopefully extend here, and you're going to be able to predict. Okay? You guys can do it a little bit better because you have more space, maybe. It's harder for me to do it. No? Okay. So our prediction is what? Sorry, Calvin? 2 hours. And Calvin, you just said, well, this would be what? 100?
Well, it takes 60 minutes to pump it to 100 meters.
Okay. There you go. 60 meters to pump to 100 meters, so you go from there. All right? Does this make sense?
Yes.
Thank you. All right, so that's the last one. So now you have 2 sections of practice to be doing, and we'll be finishing that up.